Hi, everybody. Craig from Universal Everything here, welcoming you all in to our live stream workshop, actually hosted by Extropy today. So I'd like to welcome to the stage Lawrence from Extropy. Welcome in. How are you?
I'm good, thanks. Hi, everyone. Nice to be here. Thank you.
Yeah, thanks for coming today. So this is the first of a two-part series, workshop series with you today, Lawrence. We're going to be diving into smart contract development and security best practices. So my understanding is in part one, we're going to get an introduction to secure smart contract design using the LSPs. Is that correct?
Yes, yeah, we've got a mixture of things. So I'll explain what's going to be in each one in a second. Yeah.
Okay, perfect. Well, I'm going to be hanging out here. I'll be available for if you need a test subject at any time. But Lawrence, I hope you're having a great day.
Yes.
Where are you located, by the way?
I'm in Oxford. Yeah.
Oxford. Wonderful. Nice educated place over there in the UK.
Yeah.
Fantastic. And my understanding is you were the one who introduced Jean, our smart contract lead, to smart contracts.
Indeed. Yes, I did. Yes. Yeah. Good friend. Yeah.
Oh, fantastic. Jean's a great guy. Very kind-hearted man.
Yes, indeed.
Okay. Well, I won't delay any further. Lawrence, I'm going to give you the stage and, good luck.
Great. Thanks, Craig. Hey, everyone. Nice to be here. So today it's all about security, best practices. Obviously, this is super important. So I'm hoping to give you the benefit of my experience and give you some good ideas. And I would like to hopefully impress upon you that security is something that is not there as an afterthought. It is something that you should be thinking about all the time when you're developing. So yeah, we've got our workshop, 2 hours in total, but we've got a break in between. I thought having it all together would be a little bit much, so we've got a bit of a break in the middle. Now, these notes are available at this URL, LUKSO.bootcampnotes.xyz. I'm going to leave the notes there, and in fact, I'll probably update them a little bit as well. So you're free to read them, go back to them whenever you like. So they're there for you to enjoy. All right, so what are we going to look at? Well, I'm going to start off looking at some fundamentals about LUKSO and security in general. And then we'll look at the universal profile and the security model and some of the most important aspects of that. And then in the second part, we'll look particularly at the LSPs, at the token security, so LSP 7 and 8, and look at security features around those. I've got this section I call the hands-on security lab. Probably won't have time to do much. I'm not going to be able to do any real sort of hands-on coding, but I've got some questions there for you to look at. So I've got some answers there already. So I've got some questions and answers we can go through, but also I've left some for you to have a look at, and I'll put the answers to those with these notes in a couple of days when you've had a chance to have a look at those. So that's that, and then we're going to sort of wrap it up with just talking generally about the best practices that we should be thinking about. Okay, so let's make a start. As I'm sure you know, we have with LUKSO a lot of innovation over sort of the traditional EVM. And particularly the idea, with universal profiles and then the LSP standards as well. And this gives us many benefits in terms of security. It does address many of the potential problems we've seen with the normal EVM, but it does also increase the complexity to some extent. So we do have to be aware of some things that are specific because we are using universal profiles and LSPs as well. So basic things to remember. So we're not thinking so much about externally owned accounts now. We are thinking about a profile, your universal profile. We have a permission-based access control. So this is a much more formalized way of doing access control. Previously, we would rely on third-party libraries to do this, and it's easy for that to go wrong or to be forgotten. So now we have something that is standardized, that is really obvious and very much built in, that you could use. We have interaction. We can get much more standardized interaction between contracts, which is also very important, and again addresses some of the security concerns with EVMs. And then some of the, if we're looking at things like tokens, we have these, have lots of metadata, and we have standards around those. So we're going to sort of focus really on the universal profiles to begin with. So if you're coming from the EVM environment, if you've been developing on Ethereum initially, and then you come to LUKSO, this may be something new, depending on when you moved over, I guess. But certainly this offers more in terms of user experience, but also gives us some good security things as well. So we, because we're not relying on just a single key, the possibilities for compromise perhaps are less drastic. We also have things like social recovery as well possible, because with the profile, there is much more that we can do with our profiles. The way that we can interact with contracts is much more sophisticated, and then we have this inbuilt permissioning possible as well, so we can get excuse me, really finely grained control of how we are interacting and the permissions associated with functions in our contract. Upgradability is also an aspect that it helps. I've got a little bit about that later on, so we'll perhaps look at that then. But as I said, we get this extra functionality, which is great. But with that, it does make things a little bit more complex. So we do have to be aware of the security issues or challenges that this could bring. So we have to be careful that we are configuring everything correctly. The delegation of proxies, well, yes, you have to be careful about this. Of course, you also have to be careful about this with the EVM as well, the traditional EVM. But I think with the way that UPs work, they've standardized this and made this a little more formal, a little more obvious. Okay, so some of the LSPs you need to be aware of. So we've got the base security model. Obviously, we're going to be talking about that quite a bit. The universal receiver, we'll particularly be talking about that when we're talking about tokens and doing transfers. Really, the heart of the security, as was particularly permissions, access control, is the key manager. 7 and 8, those are all about tokens, so we're going to come on to those in the next session. And then we have some other ones here I just wanted to highlight, because these do give us some benefits. For example, the enable two-step. This is something that was seen as a best practice, but you had to work out how to do this by yourself. So this is something that we've got given to us. Contract extension. This again is something that we don't have to try to work out ourselves. And then the core verification for making sure that interaction is done correctly. And then the execute relay call is all about this amazing functionality we can get with relays and trying to get things like gasless transactions. So it's getting the security around that done correctly. Now, there have been some audits of the protocol generally. Obviously, it was a while ago when it first came out. So, as you can see, by some of the top auditing companies. And I just mentioned here some of the things that they mentioned. So, just again, these are things that really you need still to be aware of when you're developing. So, the problems around delegate call. why this is specifically disallowed. We're going to talk a lot about permissions as well, and then also what you should do if you are transferring ownership. You want to make sure that you are cleaning things up regarding permissions as well. The ideas around reinitialization are really standard, I suppose, when we're thinking about contracts. You have to be aware of when something can be initialized and how to prevent that happening again. The nonce management, this is quite a nice thing. I think that we need nonces because we want to prevent replay attacks. We don't want a transaction to be replayed, so we want a nonce for that. One of the problems, I'm sure if you've been working with Ethereum for a while, you'll have come across, is when the nonce gets out of sync and it causes problems. So the version we have with LUKSO is much more sophisticated, and it helps those problems, but we still get the security. We can still prevent the problem of replay attacks. Okay, so moving on then to look at the UP security. So there's aspects to this that we need to be aware of, and we're going to particularly be looking at the 725Y, the data storage. We'll be looking later perhaps more about the universal receiver, and then looking at ownable two-step, etc. So things to think about. Obviously, and this has always been true. Ownership is critical. We have to be very clear who is the owner and how that can change. To help us with that, what we have is a key manager. So that's obviously a big plus when it comes to security. We've got something much more sophisticated because we have that. Now, a lot of the data that we are going to be using, it does depend on the context. So you do have options, and you will store it in different places according to its needs. But often we're going to be storing things using the ERC725Y data storage, and that then is secured because we can set permissions on that. So you need to be careful about how you do that. You need to have a good understanding of the security model of the data that you have, and the permissions that are needed for that. It's always good to write things down, always good to document these things before you actually implement these. So make sure you've got that very clear. And as I say, the permissioning done through the key manager. Contract extensions, don't really have much to say about this at the moment. If you need to know more, I can certainly tell you more about that. But this again is quite controlled. What they've tried to do, I think, is to make this flexible. We want our system to be flexible. We want to be able to extend what our contracts can do, but we want to do that in a controlled way. It's not just a sort of a free-for-all that could be problematic. So we have LSP 17 to help us with that and to prevent problems. But let's look particularly at the data security. I think that's one of the key areas that I want to focus on. And so this allows us to store key value data in an arbitrary way. As I say, you will have your own understanding and your own idea of what you should be storing here and what should be a sort of traditional contract variables. Particularly, I guess, traditional ones will be more about, if they're very specific just for the contract. Whereas with this, the key value data we have here, this is much more flexible. It's more about what you want to use with your profile, and it can be. It's not then as sort of tied to a particular implementation of a particular contract. It gives you much more flexibility around that. But obviously, we have to be very careful about the rules about that data and how it can be changed. And so that's what I want to talk about here, give you some idea of the principles that we need to be careful about. So the first point, really fundamental, the idea of access control. I think it's True to say, I mean, I would say this generally with any type of program, really. You should be aware of the actors within your system, and you should be very aware of the access control that they have over different parts of your system, over data in this particular case. So you need to have a very clear idea of who is allowed to modify which data. Obviously, also, you're going to have things like data integrity. You're going to have rules around how the data can change and what is valid. It's important that with different types of data, you would have different security levels. And I'll certainly come on to this more when I talk about the sort of key manager security as well. But this idea of having a hierarchy of security levels and a hierarchy with permissions is very important. And given all of that, you hopefully you get that all designed very nicely and you implement that correctly. But then also you need to think about upgrades. If you're going to in future upgrade your contract logic, then you need to think what's going to happen to the data and how that is going to be upgraded in a secure way. So what particular challenges may we see with this? Well, first of all, the data access. You have to be specific about this. You have to say who is allowed to modify particular data. Key collisions. Well, you need to be careful about the namespace. So think about how you design the namespace so that you're going to avoid key collisions. Permission escalation, then this is really just about the a very basic principle on security. The idea that a particular owner will have or a particular user will have a particular role and they will have particular privileges, and you have to be very careful about how that could be escalated and whether they can escalate it. And I'll certainly talk about that when I'm talking about the key manager. And then going to the sort of data integrity and the things like validating the format of your data. Obviously, this is something that you're going to be doing, but it still can have a security impact as well. So once again, you should be very clear what is valid and what is invalid, and have ways to sanitize data within your contracts as well. And one point to be aware of as well, the dependencies between keys. So just be careful if you do have those, then be careful how that could be handled, and could that potentially lead to a problem such as permission escalation, or could it lead to some sort of denial of service if something becomes unusable? Okay. So I've got some examples here of how you can implement security in a reasonable way. So I've just got some little snippets of code to show you here, along with these different aspects. Yeah, but these are just snippets. So yeah, obviously I haven't given you the whole contract here, but hopefully it's going to be enough to give you the idea of what you would want to do for best practices. So I mentioned this idea of using a hierarchy. So that's the way we organize our keys should be hierarchical, as you can see here. So we've got these different keys that we're going to produce. We're setting up effectively these namespaces, but calling these according to how they're going to be used. So address permissions or app, whatever. And as you'll see in a little bit later on, then you can introduce wildcards with this. So you can be looking at certain aspects of the key, which gives you a lot of flexibility. But do be careful when you're doing that you don't make things too easily or too open, that you do restrict things as possible. So that's that's really the second point here. Restrict. You need to be able to restrict the data that a particular controller can modify, and you can you can use your keys for that, as you can see here. We're restricting it according to how it is going to be used. So you're allowing app keys here, but not permission keys, etc. Then once you have that, obviously you need to implement validation when the data is being modified. So having set up these the keys, the namespace and the keys, then you need to make sure that you are actually checking those and reacting to those correctly, as you can see here. And you can make this quite dynamic. You can, as I say, you can have patterns within the keys to make this flexible. But when you're doing this, be very aware of what the possibilities would be with this. So don't make this too open when you're designing this. So try to make it as restricted as you possibly can. And it may be useful to have some mechanisms to freeze critical data as well, if needed. So that's another thing you might want to think about. Okay, so I mentioned I talk a little bit about upgrades. So certainly this is something that, I mean, developers usually do want to be able to do. Is we would like to be able to upgrade our code if we find a problem or if there's more functionality. But obviously that's quite a major thing that we're doing, and we need to be careful that we're going to be doing it correctly. And as a when I'm auditing code, if I know that a contract is, I mean, I'm talking generally here, but if I know a contract is upgradable, then this is something that would be not exactly a red flag, but it's certainly an area that I would dig into in quite a lot of detail, because it is quite easy to make a mistake about this. So we need to think about something. So what challenges do we have? Well, data preservation. It's you may not think of this as a security issue, but if you lose data, that could be catastrophic. So you need to make sure that when you are migrating and starting to use your new logic, that you don't lose data as part of that. Now, we have ways that obviously you can have things stored in the key value pairs we've just been talking about, and so that can be a way that we can still have access to data, and that can be preserved. So that's quite a good mechanism to allow the migration. But you still have to be careful that you haven't introduced something new into the logic that would then prevent some data being accessible because of that. Then looking more, I guess, at more obvious security points, we need to think about access controls. So when, as this process is happening, and as we move from one sort of logic to another, we need to make sure that the access controls are still there during this process, and that we haven't lost some in any way, that the proper access control still applies as we originally had. Permission escalation, again, this we want to make sure that these roles that the actors within our system have aren't suddenly escalated just because we have done an upgrade. So we need that. We have to be careful about changes to data schemes and layouts. I mean, that's particularly the case where we are using sort of traditional contract storage. That was one of the big gotchas that people used to have with sort of traditional EVM. with the key value ideas, then that is more flexible, so it's not necessarily as problematic, but still you have to think about the namespace for your keys, etc. And as I said, again, the backward compatibility still, you still have to be make sure of that. So how we are helped to do this, as I said, we have this idea, the ERC 725Y storage means that this gives us a nice separation of data and logic, which is sort of the first step to being able to migrate our data safely. And then you can think about your data, and then when you think about your logic, we have the key manager to help with that and to make sure that the permissioning, the access control around the logic is done correctly. So this means, we do have something that is constant. The profile is constant, but we can then upgrade the logic, and the way that interacts with the profile may change, may be upgraded, but we still have still the same data is there, and then the way that interaction happens is still mitigated by the key manager. So we still have all of the permissioning around that. Okay. So some of the patterns, I'm just sort of showing you one here. So this is around replacing the key manager to do that, to allow then so we've still got the data with the universal profile, but then we can have some new logic with the new key manager logic. This is some guidance here, so from LUKSO docs, so I thought I would just introduce that. The permissions, we have the details of that within the universal profile, so we need to be using that and reading that when we have a new key manager, and make sure that that then is configured correctly, so that it's going to reference that permission data that we have, and it's not going to miss anything, and then we can transfer the ownership. I've sort of said, I've talked about data migration as if we're actually moving things. Really, that's more of a kind of mental model of, but in actual fact, we have to do that because we have our universal profile there that is storing data. So that that stays the same, but it's just that the logic then has changed. So the migration primarily about ensuring that our new key manager is referencing the universal profile correctly, making sure that the permission data is still correct, and there's no different interpretation between how those permissions are used. Well, there could be different interpretations with the new key manager, but you want to make sure that that is correct, that that is what you intend. So other best practices generally, testing. This is something that people perhaps might not think about when you are initially creating your contracts or building your system. You'll be thinking very much about the testing of the code as it is, and maybe you'll think, well, yes, we're going to upgrade later. But what you need to think about then is, well, are we sure that we will be able to do that upgrade process correctly? Is that going to work? Because once you've deployed your contract, once you're in production, and then you come to a point where maybe you need to, upgrade very quickly. If there's something that's going to stop you doing that, then that's too late. You need to have tested this process beforehand. So make sure that testing upgrades is part of your overall test suite. And when you have this, you have the process to do the upgrade, which you're probably going to have this scripted. Make sure that is audited as well. Don't that has to be as secure as the rest of your code. So make sure that is checked. The principle of least privilege, well, this applies generally. This is something you really should follow everywhere. Just restrict as much as you can the privilege that users have concerning your code to the least possible, and then only allow them more if you absolutely have to. And then that also applies to the upgrading as well. Once you've upgraded, then you should be testing to make sure that the upgrade went successfully, because people are going to start using your new logic. If that is doing something wrong, then you want to know about that as soon as possible. So have some checks there, have some tests to make sure that the upgrade went correctly. And if you do that, then obviously you need some ability to roll back if you have to. So if things don't go as you planned, then you need to be able to go back to a previous version. Obviously, that's very important. Document everything. That's really essential. It will save you so much time and so much stress if you have all of this documented and prepared when you actually do the upgrade. You don't want to have to think, be hunting around for details. And if you can upgrade in increments, that certainly makes sense. And the universal profile, that's going to be the most critical component. So make sure that, really concentrate on that, I guess. Make sure that that's done correctly. Okay, moving on. I mentioned delegate call. Oh, sorry, just before I just realized, I didn't mention how these slides work. Sorry about that. Just so when you're in the slides, this thing here, this gives you the list of slides, and then we've got the arrows at the right here on the bottom right to move you back and forward. Sorry, I should have said that to begin with. Okay, delegate call. So this obviously is an operand in the EVM. That's always been there, and it has its uses, and particularly one of the main ones in traditional EVM is around things like upgradability and proxy contracts, that kind of thing. So it's not that it's not useful, but it is potentially quite dangerous, because what it is doing is allowing code to be executed in the context of your contract. So if you do a delegate call to another contract, you're giving a lot of trust to that contract and allowing it to execute, its arbitrary code and allowing it to change your data. So it's potentially quite dangerous. So it is tied down even more, and the key manager does this because one of the main reasons, I say, for using it, we don't really need to do. We have other ways. We have ways of doing upgrades that are safe, and so to open up this all of the dangerous aspects is perhaps unneeded. So the key manager explicitly disallows that. Where it is used, for example, with extensions, then there are strict controls around that. But it is a potentially very dangerous operation to use. So you really shouldn't be doing it. I think that probably speaks for itself. Okay. So let's move on then to the heart of the permissioning and the access control, which is the key manager. And of course, you want, with something like this, it has to be rigorous. But it also has to give you enough flexibility to be useful. So And I think the key manager achieves that quite well. So what it allows us is various permission types to do some of the standard permission, the standard things that we would need to be permissioned. So, for example, changing ownership of a particular contract. And well, the whole concept of having an owner is just very fundamental to the way we think about contracts and the way that they work. So obviously we need to be able to change that in a very structured way. We need to be able to do that safely. So that's permission. One of the permissions. Adding controllers to the key manager to allow them to be interacting with contracts. I'll come on to edit permissions in a second, because this is a very important area. We're going to dig into that a little more. Other things, making calls, setting data, signing if we need to sign. Obviously, this is the excess or functionality that we get because we've got UPs. The transfer value, the very fundamental one, and deploying contracts as well. So obviously very important areas. So how can we handle these permissions safely? How can we be sure that we're doing this correctly? Well, some details here. So as I just said, applying the principle of least privilege is one of the first things to do. So just really tie everything down, just lock everything down as much as you can. And then as things become needed, then increase the privilege for a particular controller. But do this in a very structured way. As I mentioned at the start, it's good to have this documented, have the roles documented, and be very clear about the roles that are allowed for different controllers and for different users within your system. Another, I think, general point is don't mix roles. Make sure that one controller within your system has a particular just one role and does just one thing. Otherwise, you could potentially get problems. So we can use that then to restrict what functions can be called. We can use that to restrict what data can be modified. And you really should never be assigning full permissions to anything. You should, this is like giving root access to your system. You really want to avoid that. And be careful when you are for a particular role. If you set up a number of permissions, be careful about that combination. I mean, if possible, separate them out as much as you can. But if you do have combinations, think about what that combination could mean. Is there a way that could lead to some kind of escalation? I would say generally, try to avoid combinations if you can. Now, this is just some diagrams just to illustrate that, really, of how this works and how the key manager here is preventing or restricting the what can be done with a particular contract based upon the permissions in the profile. I just took this diagram from the documentation just to illustrate really what we are doing here. All right, so that's the mental model to bear in mind. Okay, so I mean that's a very a very well designed, a very straightforward way of doing permissioning. Your permissions are stored with the profile, and then that's going to be used when you're interacting with a contract. So what do we need to look at in more detail? Excuse me. Well, edit permissions. This is really what I want to emphasize as something that is potentially quite dangerous, just because it is so powerful. Just details of what this is. So it's a flag that can be set, but what it allows you to do is to change or assign permissions for an address on a profile. So really, this is it's going back to the kind of the giving yourself or giving something else root access, because you can use this really to give yourself any permissions, or give an address any permissions if you allow this. So potentially very powerful, but therefore it could lead to problems. So it should be used very carefully, very wisely. So how is that actually used? So yeah, it's used as a bit mask. It's seen as the highest level of access, I think quite obviously as well, because it can then be used to add new addresses to permissions that we have, and then to change those permissions in any way. Okay, we can revoke permissions, so well, but that can also be a security problem as well. So it's really, yeah, a very, very powerful thing. And why you should particularly be careful about this is that, and why I've described this as a vulnerability, perhaps I should say a potential vulnerability. I'm not saying that this is a bad design, but you do have to be careful if you decide to use this, and that's because of the recursive nature of this, because you can use this then to just modify permissions in any way, so including your own permissions or downgrading others as well. So if you're thinking of, if you think from an attacker's point of view, what you would probably like to be able to do is to escalate your own privileges as much as possible and downgrade everybody else's privileges, and that would really give you free rein to do whatever you like. So potentially a great security risk, which does allow you to take complete control of a profile. I've got, if you're thinking about how could this potentially happen, then I've got some an example here. Imagine that you had some administrative reason for giving an address edit permission. As soon as you do that, then it would be able to bypass restrictions, remove other controllers, etc., as really we've just seen. So as soon as you grant this permission to any address, then you're at this risk. So particularly be careful about this. If you're thinking, you may think, well, we're going to be, I don't know, doing an upgrade. Maybe we've got an important address that needs this. Those are the types of situations where it might be tempting to give something this very powerful permission. But I would say, just generally, try to find a different way of doing whatever you're doing. It can be very, very dangerous. And other points as well. If you've designed your system so that a particular controller has this, then this could also then be a centralization risk. This could be a central point of failure, because effectively you've made something very, very powerful. You've made a controller very, very powerful, and your system is relying on that. So if there's some failure, if, for example, that becomes unusable for whatever reason, then that could mean that much of your system could fail to work, because it doesn't have the powerful abilities that this particular controller had. And if you get it wrong, it's going to be very difficult to recover from that, because you're really at the mercy of that controller, who then can, revoke your permissions, or just keep escalating their own. And also, it could be used to reduce multisig properties. So, using multisig is generally a good idea, because it reduces centralization. It reduces reliance on particular accounts and particular people. But then, if somebody has this very powerful permission, then they can effectively remove the multisig point. So, in order to reduce the possibility of this, there's some ideas that you could try. So, try to separate out the way that permissions can be edited, so that you don't people don't have all of them, the ability to do their own and all of other people's. A permission hierarchy is a good approach. So, get that established, get that documented and well designed, and make sure that people can't move up through that hierarchy when they shouldn't be allowed to. And a way to help guard that is to have the idea of multiple controllers to prevent people moving up through the hierarchy if they shouldn't. Having time locks can be a useful mechanism, just to allow more time. If something goes wrong, then it gives you more time to react. If there's a time lock that is going to give you a little bit of extra time before that permission changes, then you may give you more time to react and mitigate any problems. And I said about multisigs as well. And if you're thinking about this from a recovery point of view, then make sure that the things, the accounts that are, or the keys that are doing that, are kept secure, in cold storage, for example. So this is really just reiterating that, actually. Sorry, I said the same thing twice here. Okay. Just talking about controllers and sort of the hierarchy that you may think of there, this kind of brings us on to that, really. So your profile is going to have, or going to be expecting, multiple controllers with different permissions. So some of them, some of the roles or the semantics around that are suggested here. So maybe you would want something like an owner controller, which is going to have more access, high privilege. They're going to be doing administrative tasks. Then you would have the everyday controllers that are doing the everyday tasks, and obviously that they should be much lower down in the hierarchy than the owner controller. You can have controllers that are there for application specific roles, and you can restrict those and just allow them a role in for a particular application. And then you should also be thinking about recovery, certainly, but have things that have controllers that are just there for recovery and cannot be used outside that type of role. So I would say, generally, try to make these things quite specific in the way that they are being used, and try to really isolate them. Try to make them quite distinct from each other, and make sure there's no overlap in the permissions, and there's no possibility that you could have some sort of privilege escalation. Yeah, so there you go. There's the conclusion about the edit permissions. Really, one of perhaps the most important things to be aware of, because of the consequences if it goes wrong. Okay. coming on to just some other things that I mentioned. Some of the useful mechanisms we also have. The ownable two-step. So this was a good practice back in the day because we would like to transfer ownership of something, but do that in a safe way. And the problem, of course, is that if you just do it directly, just transfer ownership completely in one step, then you've got the possibility of getting it wrong, transferring the ownership to the wrong person, to the wrong address or whatever it is. And so the idea behind the two-step approach is that you propose the new owner, and then they must explicitly accept ownership. So they have to be aware that they're going to be the owner, and they'll then accept, and you've got more control over the whole thing. And as well as stopping kind of accidental transfers to the wrong address, then that also ensures that the new owner is capable of the ownership of whatever it is they are going to own. When you're doing this, though, do also be aware of the permissions that are involved as well. So have those permissions been configured correctly for the new owner? Particularly, have the permissions been removed from the old controller because they should no longer be used. So you don't want to be in the situation where you have a new controller, but the old controller still has permissions. So make sure that those have been removed. Sorry, I've forgotten the point here. I suppose just to make sure that this is cannot be repeated. The idea we've got nods. Okay, I think I've come to the end of my notes for the first session. I did sort of rush through things a little bit, but hopefully that made sense. As I said, the notes are available here, so make sure you have those. What we've just got a couple of minutes, but what we'll do after the break is I'll go on to the second part. We're going to be talking particularly about token security and some of the features around that, and some of the flexibility that we have and the ways that we can make sure that, say, transfers are done safely. I've got some further examples for you to look at, and then we can just have a quick look at the sort of best practices in conclusion. All right. And as I noted earlier, the hands-on part, I do have some examples, but some of them I've left for you to complete as well. What I will do is, if you go to the root of these notes, you just got the links here for the first two sessions notes. But what I'll do, I'll have another section here for the lab, giving you some examples for the particular things that I've proposed, and then you can check those yourselves to see what you think. All right, so I think that's everything. So I'm finishing a few minutes early, but yeah, hopefully that's given you something to think about, and we can have a break now. You can let that settle in, and then we can start looking at LSP 7.8 and the sort of token aspect of things.
Yeah, fantastic, Lawrence. I appreciate that. Now's the time for everybody to use the bathroom, hydrate, maybe get something to eat, and we'll be back in roughly 1 hour. Okay, wonderful. Thanks so much, Lawrence.
Thank you.